All right, and so now when everybody has had a little bit better of experience finding those sine and cosine values of the common angles on the unit circle, then we can start speeding up the pace a little bit here. But let's move on to quadrant 3. And so, and just to remind everybody again that when your terminal point, and of course counting from the counterclockwise positive rotation, then when your terminal point was here, it's the pi angle, and coordinates on the unit circle is being -1, 0, or cosine of pi equals -1, and then sine of pi equals 0 as a reminder. And so now let's let our points, our terminal points, rotate down to that other point right here. And that point here on the picture is where my angle theta be equals to, say, 7 pi over 6. Or in degrees, this is the angle theta equals 210 degrees. And so now, in this way right here, then I can see that the x coordinates can quickly be still the -√3 over 2, and the y value this time is also a negative value, and it should be -1/2 as being described in the picture right here. And so in that way, briefly reasoning through all that here, and the argument can be made similar to how we've seen in the earlier videos. Then here, cosine of 7 pi over 6 now equals -√3 over 2 for that little length right there. And sine value of your 7 pi over 6 is equals to -1/2. And then when your angle, the terminal point travel to this next point here, being one of the common point, a common angle on a unit circle, the angle created here, the central angle created here, the angle theta, in this case being the 5 pi over 4, or thinking in terms of the degrees right here, it's the angle 225 degrees. Then at that point, let's quickly draw the triangular setup, and now we can quickly recognize the x and y coordinates of that. Okay. And so in that way, my x coordinate in quadrant 3 here, and that length right here, we have seen all that arguments throughout our past videos. And so here it's a negative √2 over 2, and the y coordinates in this case is also it's pointing downwards below the x-axis, so -√2 over 2 as well. And so now I can say cosine value of the angle 5 pi over 4 equals -√2 over 2, and my sine value of a -2, my apology, but sine value of my angle 5 pi over 4 equals -√2 over 2. Alright, and so now when we get to this angle here in quadrant 3, the angle itself in radians is a 4 pi over 3, or thinking in terms of the degrees measurement, and this is the angle 240 degrees angle. And so to find out the sine and the cosine value for this angle in particular, then let's draw the x and y coordinates here. So here's my x coordinates and here's my y coordinates. And so now it makes sense that x coordinate in this way is a negative. As far as length, it's 1/2, but it's negative as a coordinate. And then similar arguments with the other video lessons we've seen. Then y coordinates here is negative square root 3 over 2. And so now I can say that cosine of the angle 4 pi over 3 equals negative 1/2, and the sine value of the angle 4 pi over 3 is equals to negative square root 3 over 2. And in the last quadrant of the unit circle, namely Q4, don't forget again at this point right here, the 3 pi over 2 angles, then we got x coordinates being 0 and y coordinates being negative 1. But now, and still, I'm going to keep the pace a little bit up because everybody at this point have had some good experience with that. So now when my terminal point is here, making a central angle of 5 pi over 3 in radians, or it's the in degrees, it's the angle 300 degrees. Then when switching over to quadrant 4 here, then the x coordinates gets back and become positive. And let me quickly demonstrate the x coordinates here. The x coordinates is right here. So that's my x coordinate. And so as far as the length, we can recognize that it's that length being 1/2. So, and for the coordinates, it's going to be a positive 1/2 coordinates. And then the y coordinates here, in this case, it's that same length but below the x-axis. So now it's still negative square root 3 over 2 due to the fact that this is being a 30, 60, and 90 triangle. And so now I can say that cosine of the angle 5 pi over 3 equals positive 1/2, whereas sine value of the angle 5 pi over 3 equals negative square root 3 over 2. Then when your terminal point moves to here, and right there, which makes it a, in terms of the central angle, that rotation now has been theta equals 7 pi over 4, and in degrees, it's the angle 315 degrees. And so for this angle right here, once again, the x coordinate is how much that is right here, being positive, and the y coordinate same length but being below the x-axis, so it's a negative y coordinate still. And so here, as far as length, we're looking at x coordinates being from the square 2 over 2 length, but it's a positive sign. And then y coordinate still the same length, square 2 over 2, but now being a negative length. And so now cosine of the angle 7 pi over 2, I'm sorry, I mean 7 pi over 4. Cosine of 7 pi over 4 now legally equals positive square root 2 over 2, and sine value of 7 pi over 4 equals a negative square root 2 over 2. All right, and the last common angle on the unit circle is when your terminal point is here, and so as far as the rotations it has made, when it gets to there, it has made an angle in quadrant 4, up to quadrant 4, it has made an angle theta equals a 11 pi over 6, or in degrees, it's the angle 330 degrees. And so now once again, to drawing out the x and y coordinates of this terminal point, it's going to reveal the 30, 60, and 90 degree triangle. And so now we're going to look at the x coordinate. In this case, in lengthwise, it's being a square root 3 over 2. But being the coordinates right here, and that's a positive square root 3 over 2. And then the other length is a 1/2. But since the coordinates for y is below the x-axis, so now we're looking at negative 1/2 for the y coordinate. And so now I can say cosine of 11 pi over 6 equals square root 3 over 2, and sine of 11 pi over 6 equals a negative 1/2. And so now you've made it through looking through the sine and the cosine value of all the common angles throughout the unit circle in a positive direction. All right, so now a minor detail needs to be mentioned here. But if you are worried about what if in some problems we have to work in degrees, will cosine value and sine value, will cosine function and sine function turn out the same value as in when we were working with radians? It sure will. And so let me bring up some quick example. Let's say cosine of the angle 30 degrees. But now definitely you need to indicate that degree sign right there. But cosine of 30 degrees is positive square root 3 over 2, because in the end, expressing your angle in radians or in degrees is just a way, a style to express the angle measurements. But in the end, cosine is to refer to the x coordinates of the terminal point. And so 30 degrees or the pi over 6 angles, they are exactly at the same terminal point. And so now you have your right, I have my right to say that cosine value of the 30 degrees equals square root 3 over 2. So nothing special about that. And same way that you're saying sine of the 45 degree, for example, that is, so 45 degrees is a different way to express the angle, but the terminal point lands into the same point right here. And so for that angle, the x coordinates is here, and that will be square root 2 over 2. And then what about negative angles? All right. And so if once you know where your starting point is at right here, then thinking about your angle is making your terminal point is traveling in a way that is making a negative rotation, and here let's say it has rotate for the angle of negative 45 degrees. Then the cosine of negative 45 degrees. So in the end, like I have expressed, cosine value and sine value simply indicate how much x coordinates or how much y coordinates being produced when your angle reach to that particular measurement. An angle closely relate to where your terminal point is at. So in the end, being a negative 45 degrees angle, it's just the way how we're seeing it, but it's exactly, remember the term coterminal. So this negative 45 degrees is here, but it's coterminal with what? The angle 315 in positive degrees, or it's also in radians. It's the 7 pi over 4 angle. So that means what? It's the same as the cosine value of 7 pi over 4, coterminal with 7 pi over 4, even coterminal with 315 degrees, cosine of 315 degrees. And so all of these values all turn out being one value, the positive square root 2 over 2. And then likewise, sine of negative pi over 6, for example. So once again, think about your starting point of the terminal point is here, and then making a pi over 6 rotation in a negative way, we're landing right here. So this is a negative pi over 6. And so negative pi over 6 is coterminal with a positive 11 pi over 6. And so thinking about sine of negative pi over 6 is exactly the same. The same with sine value of the positive 11 pi over 6. Or the same as the sine value of the 330 degrees in the degrees expression. And so that means all of these values are all turned out because once again they are coterminal. And so they all turn out being negative for vertical coordinates here, negative 1/2. So sine of negative pi over 6 equals the negative 1/2. All right, and so our last concern now is that, so what about those angles being more than 360 degrees or more than 2 pi? So remember we talked about those kind of angles that made a rotation more than one complete rotation. And so let me put up one quick example here. But let's say, let's find cosine of 9 pi over 4. And so remember that when we were learning about those angles being more than one rotation, then what I see now is that from where this angle is within one rotation, then this angle here is a pi over 4 angle. If we're looking at that angle as an angle within one rotation on a unit circle. However, the same angle here, pi over 4, if we from there we go one more complete cycle, so one more complete cycle and land into the exact same terminal, then we're gonna have what it means there is we're having a pi over 4, but we add with a one more complete cycle, 2 pi. So we ended it up with being 9 over 4. And so I just want to remind everybody that 9 over 4, 9 pi over 4, and pi over 4, they are coterminal. These two angles are coterminal. So in that way, now I can say that cosine of 9 pi over 4 is exactly the same value, because being coterminal, it means x and y values are exactly the same because they have the exact same terminal point. And so cosine of 9 over 4 is exactly the same value with cosine of pi over 4, which gives me the value square root 2 over 2. And then now we'll worry about, so looks like all of my explanation so far has been focusing on those special angles on the unit circle, where a lot of time people refer to those as the common angles, like say the 30 degrees, the 60 degrees, the multiple of 45 degrees, and multiple of 30 and multiple of 60s. But now what about when we have those non-common angles? So for example, what about when we having a when we need to find sine value of a 25 degrees? And so when it gets to this, we do need to use a calculator for some assistance right here from a calculator. Or what about cosine value of the angle being a pi over 5, for example? So these are all the kind of the calculation that we now need to turn over and use turn over to a calculator and let it help us. All right, so now let's briefly and quickly have a look at to see how we can use our technology here, the TI-83 or 84 calculator, to do a calculation, a trig function calculation here, and specifically sine and cosine value. And so now let me proceed with sine of 25 degrees. And so one thing before we proceed here, one thing you must be aware of is that you need to tell your calculator to switch over and work with degrees mode, work in angles with degrees. And so to do that, you're going to hit on the mode button right here, and then it brings up a menu with quite a few items. You want to use the down arrow key right here and navigate down to the line that says, and you can see that right now it's currently blinking radians right there. So you might want to stay right there in that line. But then see, as for now in my calculator right now it's in radian. So that means if you want to work with angles in degrees and come out with correct results, you have to. So now in that line, you're going to use the right arrow key and turn over to degrees and hit enter. And now it's switch mode right here. And now just quit out second mode. It's going to quit out of that setting right there. And so now your calculator has a sine key right here, which is right there. Hit the sine, and then we're going to enter 25 degrees. And now the sine function programmed in your calculator will automatically understand that this input value is an angle expressed in degrees. And so now hitting enter, it's going to give you the result that we want. And so back to my board right here, then sine of 25 degrees is 0.4226. And how many decimals, it all depends on different exercise problems that it's having different requirements there. And so cosine of pi over 5. Let's find out what cosine of pi over 5 is. And once again, this is a non-common angle here, so we definitely need to use the calculator to get that value out for us. And so, but notice that my pi over 5 angle here is being expressed in radians. And so now we need to go back. And so back on to my calculator on the screen here, then I need to go back to the setting here, by hitting mode, and navigate down to the line that does the adjustment for angles, and I'm going to need to make sure we all select radians. And so hit enter, and then second mode to quit out of that setting page. And now we're about to evaluate cosine value of the angle. So I'm going to go hit on the cosine key, and then now the angle here is a pi over 5. So notice your calculator, your TI-84, does have that pi value being in precise value. So I'm going to go second caret, and it's going to bring up pi, but then here it's a pi over 5, and type hit the closing parentheses, and now I'm ready to hit enter and get the final calculation. And so cosine of pi over 5 equals 0.809. Oh, and so that's and usually these It just only appears as an approximate of these values.